Okay, we're going to take a look at the concepts of relations and functions. And you've probably heard about these and you've been using these terms for some time, maybe even have a pretty good understanding of what they mean. But we'll just quickly kind of look at them again, and then we'll do some specific things with respect to relations and functions. So a relation in math can be thought of as or defined as a rule of correspondence. And that's a very traditional way, correspondence. So something corresponds to something else, specifically an element of one set. Let's call it set A. Okay, so set A has some things in it. The elements in that set, say A1, A2, etc., have some rule that relates them to elements in some set, call it B. So A1 may relate to B1 in accordance with some rule called the rule of correspondence. Another way to define a relation has to do with ordered pairs. So ordered pairs say x, y, and it implies that the correspondence between x and y is defined in some meaningful way. So again, there are perhaps elements in some set x, x1, x2, and elements in some set y, y1, y2, and that the relationship between x1, for example, and y1, or x1 potentially and y2 is meaningful. It's not just random, that there is some kind of meaning behind it. Okay, so a relation is really just a way of relating elements from one set with elements from another set in some way that makes sense. The rule might be simple or it might be complicated. So, for example, we could say that there is some relation defined as y equals 2x plus 1. Now, that's a relation between elements of a set x. We'll call this set x, much like we did over here. This is the big set x. I'll make this kind of bold. And in that set are elements. x1, x2, x3. Those might be numbers, or they might be objects, or they could be people. They could be pieces of data. Could be a lot of things. But then there is some rule, and this is back to the idea of rule of correspondence. There's some rule that relates elements of x with elements of y. I make that kind of bold. So y1, y2, etc. And in this case, if we have x, our set x, and it has elements 1, 2, 3 in it, then our rule would be 2x plus 1. So the rule would say to take 2 times the element in x, so 2 times the element 1, and add 1 to it. So that would be 3, and that would give us the value 3 in our set y. Okay? And similarly, if we did it as an ordered pair, we'd say that the relationship, or the ordered pair 1, 3, is related by some meaningful expression or something that is meaningful. In this case, it's meaningful to say take 2 times the number x and then add 1 to it. So 2 times 1 is 2, plus 1 is 3. Similarly, 2 times 2 is 4, and add 1 and we get 5, so we have the ordered pair 2, 5, wherein 2 and 5 are meaningfully related. Okay? So enough of that. Now, what is a function? Well, a function is just a special form of relation. A function is a relation where every, now note this is important, every element in the domain is related, or we could say is mapped to exactly one element in the range. Now that begs, what is domain and what is range? Well, in our examples above, the domain is x. That is the independent variable. The independent variable. That's the variable we get to pick. So we get to pick x first, and then the rule results in the range, the value y. That is the dependent variable. And that's what results by applying the rule to the element in the domain set. So our domain, also called x, we have a value of x such as 1. We apply the rule to it. The rule says take 2 times 1, add 1, and we get 3. It gives us the ordered pair 1 and 3, where they are related in a meaningful way. So what does that mean? That means a function can have only one corresponding value in the range, and every element in the domain has to have a corresponding value. In other words, we can't leave out any elements in the domain. So if we have a domain x, our domain x, and in our domain are numbers 1, 2, and 3, and 4, then we must have a rule that satisfies this condition. So every element has to be related, so we need a rule where every element is related to exactly one element in the range. Okay, so if we have a rule like 2x plus 1, we can check to see if that rule would satisfy this. Well, 1 would map to 3, so it would give us 3, 2x plus 1, 2 times 1 plus 1. 2 would be 5, 3 would be 7, and 4 would be 9. So if we have a range like this, and if we have a domain like this, and if we have a rule like this, we have the special case of a function. Because every element, 1, 2, 3, 4, all get mapped to exactly one and only one element in the range. Now let's look at something that is not a function. So we want to look at something function, and we want to say something where we have perhaps no function, but instead just a relation. So we want to find something that is not a function. So an example might be, take our domain here of x having in it the elements 1, 2, 3, and 4, and a range y having elements 3, 5, 7, and 9, and we might have a rule, we're not going to write what the rule is, but some rule such that 1 maps to 3, 2 maps to 5, going to go around there, but 3 maps to both 7 and 9. So in other words, some kind of rule that gives us 2 answers in y. Okay? Now that's not a function for 2 reasons. One is we didn't include the 4. Remember, every element in the domain must map. And every element can only map to one thing. So this is a non-function, it's still a relation, but it failed both tests. So that would not be a function, but it would be perhaps a perfectly good relation. Okay? An example in mathematics of a relation that's not a function would be something like x squared plus y squared equals 16. That would not be a relation. Excuse me, that would not be a function. That would be a relation. Okay, but it would not be a function. Okay, more on this later, and we'll have a little bit of an exercise so that you can work on functions and relations.